Welcome to an Azure Incident Retrospective. I'm David Steele.
And I'm Simon Kuba. We both work in the Azure Communications team.
In addition to providing a written post-incident review after major outages on the Azure platform, we also host these retrospective conversations.
You're about to watch a recording of a live stream. We invited impacted customers through Azure Service Health and Azure Service Health Alerts to participate in a live webcast featuring our relevant engineering leaders.
By joining one of our live sessions, customers and partners also had access to a Q&A experience to ask questions of our engineering experts during the event.
As you know, building reliable applications in the cloud is a shared responsibility. So this conversation includes our learnings at Microsoft, as well as guidance for our customers and partners to make their services more resilient.
We hope you enjoy the conversation that follows, and we really welcome feedback on how we can make these sessions even better. So feel free to scan the QR code below the recording for our 2.5-question survey.
Today we'll be talking about an incident with the Azure OpenAI service. It predominantly impacted customers in the East US 2 region. There were two incidents, one on the 27th and a recurrence of the same issue on the 28th, where impacted customers would have experienced error responses and failed requests following a recent deployment that we did to the service.
That's right. So to talk us through the impact and our learnings, I'd like to introduce a couple of engineering leaders joining as our guests today. On my right-hand side, we have Chip Locke. Chip is the principal architect from our Azure AI platform team. We're also joined by Daniel Huang. Daniel is our senior software engineer, also from the AI platform team. Thank you guys for being here and talking us through this today.
Yeah, thanks for having us.
Thank you. Chip, maybe I could start with you. Before we get into the incident itself, could you help us understand some of the ingredients that we're going to be talking about today for the Azure OpenAI service? We spoke, the DNS actor or actress played a huge role here. Could you talk to us a little bit about how Azure OpenAI uses DNS or interacts with DNS?
Yeah, absolutely. So we have a multi-layered system. We have an API management front end. This is where user traffic enters our system. We have a middle tier, and that is what we're going to spend a lot of time talking about today. And then we have a large back end full of those expensive GPUs that we all love to use.
Very good. Now, it's interesting, Chip, we want to talk about the regional deployment model here, because I think that's something that not everyone is super familiar with when it comes to OpenAI. Sammy mentioned in the intro this only affected East US 2, but depending on how customers deploy, customers may or may not know that their stuff is being processed in East US 2. So remind us how that model works.
That's correct. So there are different offerings of our inferencing services. There is an offering that lets you specify precisely the region where you would like your traffic to handle. And then there's also a global offering, and that offering is built to send your traffic to where we have capacity. As I mentioned, and as people are very well aware, there's a lot of work to get GPUs available. In the interim, we have a tier of traffic where you can specify as a customer, send my traffic where the best place is for it right now. And so those users would have been unfortunately impacted when we have these dips in availability in a region, particularly a large region where we do have a good amount of capacity.
All right. So if I'm a customer and I want my data to stay only in this region, I can select that. But if I say you manage it the best way for availability and so on, I click global and it's kind of distributed. You guys decide how it works.
That's correct. Yes. And so we have a set of customers where they have sovereignty requirements, or they just very specifically say I have latency requirements. Those sorts of things keep me exactly in this region. We have many other customers who make the choice for global because that meets their business needs.
Magic. If we can talk a little bit about change and change management. We know that change is a very important thing that we do because it's the #1 cause of outages within our industry. And so when Azure makes changes, we do this thing, the safe deployment practices, which we speak a lot about on these and offline as well, where when we make a deployment, we don't just change the service. We make very gradual changes, staging environments, and those changes could be code deployments or they could be configuration changes. Could you talk to us a little bit about how Azure OpenAI makes changes? Does it follow that same philosophy and process?
Yes, absolutely. We start with development environments, and that is where developers, engineers work on the service. Those are fairly open. We do use our change systems in those environments. We want to ensure that those work. We iterate on those to get them right. Following that, we'll proceed to a staging or pre-production environment. You might see it called PPE sometimes. It's the same as pre-production. And then beyond that, we will start to progress in what is the standard Azure production safe deployment practice model, which is early update access program, or EUAP, you may have seen that. And then we progress through regions looking to go to smaller regions, a couple at a time at most, and then gradually open that up to deploy once we have full confidence in the release.
Got it. That's how things should work. We'll get to how it
yes.
did work. Daniel, great opportunity to bring you in here. Let's now fast forward to the 27th of April on this fateful day of this incident. The initial occurrence happened. What can you help us to understand about the trigger event here? We try not to talk about root causes, but just chronologically, what happened here? There was a deployment that was supposed to be changing non-production. What happened?
Yeah, so the system was originally designed with isolations between the production and staging environment. However, the isolations was not strictly enforced. So that means that when a deployment was intended to deploy to the staging environment, but it can actually access the production's resources, and the DNS resources has got modified. So that means that as a result, the production traffic has been getting redirected to the staging backend resources.
Just to put a little bit of clarity into Daniel's answer there, broadly speaking, our production and staging environments are not intermingled. This is an edge case that we hit where we have a shared infrastructure DNS zone. It's not a customer-facing zone, but within our system, we were using the same zone for our infrastructure endpoints. So that middle tier, you have the API front end, that's all production, and then our middle tier is that same production. However, both the production and staging environments were sharing the same internal DNS zone, and our deployment to staging was able, unfortunately, to modify that production DNS zone as a result.
Yeah, see, this is the interesting part that stood out to me. When customers hear this non-production change was able to change prod, obviously people worry about environment isolation, right? So what I'm trying to understand is how were those boundaries intended to work, and kind of what went wrong?
Yeah, I absolutely would understand the concern. I do understand the concern, and here what went wrong is basically what I said, where broadly speaking, our production and staging environments are completely separated. They are in different Azure subscriptions. There's different access groups that are required. There's different levels of ability to deploy. So we do take our production guardrails extremely seriously. Certainly, it's not possible today to deploy code into a production environment when you meant to go to staging. Unfortunately, we were utilizing, as I mentioned, that same infrastructure internal DNS zone to house records both for our production and staging environments, and that is where that cross-contamination was unfortunately able to occur.
Got it. Makes sense.
A quick clarifying question as well. I know that at times it's really hard, particularly with mammoth regions like East West and East West 2, to replicate some of the deployment. And so we're trying to bring production and our staging environments closer. Was that one of the trade-offs here that we used, where we had that shared resource?
That is, yes, that is
Okay.
exactly right. That is one of the trade-offs we wanted to make. We do want our staging environment to look as identical to production as possible, so that we have the most confidence in our changes before we put them in front of our users.
So a follow-up question as well. When impact did occur, we saw that impact wasn't typically. Sometimes when we have bad code that gets shipped, impact is almost immediate. When I look at the quality of service graphs, I see it drop here. But this was gradual impact, and this was to do with our DNS time to live, and that also hindered detection. Could you walk us through a little bit about how that DNS relationship and why the impact was kind of gradual over time?
Absolutely. So on the day that the initial incident occurred, I was actually on the call. I was on the bridge assisting in diagnosing. I was not the on-call engineer at the time, but jumped in when we saw that this problem was occurring. Unfortunately, we believed that the root cause was something other than DNS. We were mistaken. While that was ongoing, our DNS records are configured for these internal zones with an 1 hour TTL or time to live. We do that. We do not use a faster twitch TTL in order to reduce the number of DNS lookups within the system. That provides a small but noticeable performance improvement for end user traffic, because their traffic is less likely to experience additional latency as we have to do these DNS lookups for each hop in the system. These records change very infrequently. They're typically write once, read always, and then you are done. And in this case, that bit us, because when we then were able to both identify the issue, realize, yeah, hey, this is DNS, go in and mitigate that directly, it did take a bit of time also for recovery to ramp in, because you had these DNS results that were also cached for an hour on that API management front end that took time to come out of the cache.
Got it. So I wanted to understand a little bit. You talked how we kind of investigated it and mitigated it. How do we feel about the detection here? It sounds like there was eventually alerting that fired, but because of that gradual issue, maybe that was not as fast as it could have been?
I think that's accurate, and we're going to talk about this a little bit more, I believe. Both the detection was a little bit behind, although we feel generally pretty good. We got the signal pretty quickly that users were seeing errors, and that anomaly showed up very early in the incident. A lot of what happened was we detected, and then the time to mitigation was held up in large part because of what I mentioned, which is we believed there was a different root cause. Spent about 10, 15 minutes investigating, going down that road, realized this is just not just DNS, but, oh, this is DNS. This has nothing to do with what we thought it was.
It's interesting. And I know on previous incidents as well, when we've updated our DNS due to an issue, once we've done our part, because of the TTL, it often takes time for customers to see recovery as well, depending on how quickly it refreshes, which plays a role in our time to mitigate as well. Daniel, maybe I'd love to bring you in here. Mm-hmm. That was the first incident. Mm-hmm. And once we kind of understood what had happened and Chip was on the bridge, and it sounds like we removed this bad configuration from the records, but it was still present in our repository. And that caused a second event to reoccur. Could you talk us through the recurrence of this second event here?
Yeah, so in the initial mitigations, we did not fully bring the systems back to the safe state. So specifically, we did not remove the permissions within the staging environments that can access the production resources, which means that the future deployment is still capable to access and modify the production resources. And secondly, we use infrastructure as a code. So that means that we save all our configurations into our repo. And we kind of treat that as a source of the truth. So we did not remove the problematic configurations within the repo. And lastly, the same DNS configurations has getting reused by our non-US peer teams, which basically indicate there's a miscommunication there.
That's really interesting to understand this idea of we'd fixed it here, we'd corrected the records, but in the repository, next time we spit out something, that part wasn't fixed. That's how it was able to reoccur.
Yeah, and I want to dive in there just a little bit to add some context. When the bridge was concluded, we had mitigated the incident. The records were manually restored to what they were intended to be. We certainly did not intend for any of this configuration to be long-lived. The work was begun immediately to undo the impacting changes. And what Daniel referred to is that just as we are a global team, unfortunately, there was a gap in communication where we did not successfully communicate to our partners, our team, globally, do not deploy any of this until we've done the full cleanup that was necessary. And that, unfortunately, that work certainly was going to happen within 24 hours after the incident occurred. Unfortunately, the recurrence caught us before we were able to complete it.
Yeah, but it's great to understand, and now we can picture between the repository and the communication, now we can picture how that happened in that recurrence. It's very rare for us to have a recurrence like that, so we just wanted to understand it better. Now, Chip, I'd love to pivot over to our learnings and repairs here. Obviously, the most important question on people's minds is, what safeguards can we put in place around DNS record modification? Can you talk us through that a little bit?
Yeah, absolutely. So the very obvious, in hindsight, answer is completely separate those infrastructure zones so that we have a separate one for development, separate for staging, separate for production. That would have been correct up front. There were reasons we chose what we did, but in hindsight, certainly poor reasons. So that work is being completed as we speak, quite literally. The other things we found, so in that initial investigation to mitigate, the problem that we thought we had was related to TLS certificates. It had nothing to do with TLS. However, we did detect a deficiency in our system where it is possible to impact within a single region a TLS configuration across that entire region with a single change, and we're also doing some work to bring that out. In addition to that, we're doing more work to detect these sorts of events very quickly and ensure that they're routed to the correct team. So my team is an infrastructure team. We don't typically get immediately paged for issues of this nature. So there was a separate team that was called in. That also adds time to mitigate. We are adding more comprehensive alerting so that we will be called immediately and so that we can assist other teams whenever we detect anomalous traffic shifts like we saw in this incident.
Magic. And Chip, if I can stay with you for a little bit, in the PIR repair items, we spoke about monitoring. There were 2 items on monitoring, but before I get there, because I have a question on it, but whenever I speak to some of our SREs, one of the concerns they talk about is, look, more monitoring isn't always better because it can dilute our signal to noise ratio. And so while the heuristic is for us to say we're going to monitor everything, I know that it comes with noise and dilution, but we spoke about monitoring for traffic deviations and we spoke about monitoring for ingress request failures, both in the PIR. I wanted to understand, number one, the difference there, and number two, Chip, as principal architect, are we going to dilute our signal to noise ratio here?
I'm so passionate about this subject. So let me talk about and Daniel's laughing because he knows, because I talk about this a lot on our team calls. So let me talk first about the 2 signals and how they are distinct. So the way that this issue manifested was to divert traffic from our production East US2 region to our staging East US2 environment. That traffic deviance, where we just see a very steep drop in one area and a very steep rise in another area, that's where we want to talk about the traffic shift alerting on that. And then the error rate alerting, we have not typically directed those to the infrastructure team because rises in error rates do periodically occur due to systems that run on top of our platform, on top of our infrastructure, and we are not the appropriate team to handle that. However, in certain cases or for certain kinds of errors, and the way these manifested, without going too deep into the weeds, is with a 0 error code, a 0 HTTP error code, which is extremely uncommon and isn't even returned directly to the user. That makes this something that we can detect and that we can alert. And to go to your question about that, alarm fatigue is often used as a sort of a term of industry. We do take that very seriously because we want every alert we get, to the best of our ability, to be quality, to be actionable, to ensure that there is not that fatigue so that we don't miss real things because of noise. And that is where we have some caution around adding new alerts, around how we tune our alerts, because we do want to make sure that we're actually delivering our best to our customers.
That's really cool to understand some of the trade-offs there. I think it's too easy sometimes for people to say, oh, we'll just add monitoring, but it's great that you're thinking that through. And in this case, there is some additional monitoring that is going to help here. The other repair item that was listed, or the last one that I found interesting, was auto-fail logic. We mentioned when a change includes, colliding or conflicting DNS records, we're now going to fail automatically. Help us to understand that a little bit.
Yeah, absolutely. So in our system, we, as Daniel mentioned, we use infrastructure as code. That goes through a build process, and then that is subsequently deployed. At build time, we are adding safeguards, and this again is happening as we speak, effectively, to look at our entire sum or set of configurations and find any cases where DNS records exist in configuration A and configuration B that would point to 2 different destinations. So any opportunity there will simply fail our builds. We will not have a build to deploy, and so we cannot deploy bad bits.
That's it. So if we were to say, my follow-up question was going to be, once we've got all these repair items in place, what happens when we have this kind of conflict again? But I think you've just answered it, but you're saying it can't happen.
That's correct, yes. So part of our process on the development side is that we have a main trunk branch where all of the production code lives. We have a release branch. And then developers submit pull requests and say, I would like to make this change. When they submit their pull requests to go into that trunk main branch, part of that process involves doing automated builds or continuous integration, it's referred to. Those builds will simply fail and their pull request won't be able to be completed. So bad code can't even get into the repository.
I like that, rejecting the question. What happens if it were introduced? It can't be introduced. Chip, we've covered a lot about kind of our learnings and repairs at Microsoft, but as we always talk about, building reliable systems on Azure is always a shared responsibility between our customers and partners and us as the cloud provider. So just as we try to learn from outages, what could customers have learned from this? Right? How could they have weathered the storm better here? Are there best practices around BCDR, things like that?
There absolutely are. For customers who have the opportunity to do this, if you can pick regional configurations for your inferencing endpoints, those are good. If in addition to that, or generally in addition to that, you will want to have a second regional deployment. Because it's usage billing, you won't be billed if you don't use it, but it is there as a backup, a fallback if you need it. You're able to then manage your own traffic as a customer when you detect an issue within a region. So let us say you wanted East US 2 and West US 3 as your two endpoints, and you typically are going to use East US 2. If you detect any anomalous behavior in East US 2, you can move your systems to your West US 3 endpoint. We do recognize this is not an option for our global customers, for example. Global capacity, unfortunately, is not covered in that way for you, but where customers have the opportunity, where data sovereignty works for you and you can do that, we do encourage those configurations.
Sure. Okay, that's good to understand where it makes sense based on your scenarios or your customers. Okay, very good. I've saved my last question for Sammy. Since Sammy runs our incident communications team, how did we do on comms?
Generally speaking, we like to get communications out quickly to customers. We've found that over the years, the best way to do this is through Brain, which is our automated communication system. It typically communicates to customers within 15 minutes of impact. The way that Brain works is it detects spikes, anomaly spikes, and it uses that information to communicate to customers. TTLs and expiring cache is problematic. And because impact was gradual over time, those Brain thresholds don't trigger. Now, some of the repair items that Chip is talking around and some of that detection, that's stuff that we can build Brain off. But once humans are involved, we're slow. And we were slow to this as well, which is problematic for customers because when their requests are failing and they don't have communications, it's a problem. Once we got the communication engine rolling, once all the right things were happening, we were there. We tried to provide customers workarounds where we could. We tried to provide information. In my mind, I like to think of one of the jobs of the communications team is to tell customers everything that we know. Sometimes some information doesn't make it through. And so like even connecting this to the previous incident on the second one, we were late to doing that. And it's not that it would change the outcome, but again, our job is to really bring customers into the war room, into the operating theater and say, here's everything we know. If you were to call our CEO, he's going to give you the same information here. And I think that's one of the responsibilities we have. We have a way to go, and we know that it's never going to be perfect. But I think when we look at our North Star, our benchmark of what we want to do, we have work to do to get onboarded to Brain so the customers are notified quickly. And that's just a quick and dirty communication, say it's an Azure problem, not a you problem. And the next piece is to provide as much information as we can. And we spoke about repair items last time. We want to start leveraging some AI and some bridge transcripts to say, hey, here are a few things that we haven't told our customers here, and we might need to author it and clean it up a little bit and remove any proprietary information. But we have work to do in this place. So I feel very optimistic about our future. I feel that the path that we're heading is right, but absolutely we still have learnings.
Cool, good to understand. So we've got some learnings from Azure OpenAI in terms of how we're improving for this kind of thing, and we've got some learnings from the communications team. That's great. Well, thank you. Thank you for joining us. Thank you, Chip. Thank you, Daniel. Thank you to our AV crew, but mostly thank you to our customers and partners for joining us. We know that we don't want the cloud to be some black box. We want to introduce you to the humans of Azure and kind of explain what went wrong, how we responded to it, and ultimately what we're learning.
Absolutely. The other piece for customers, if you are watching this or even if you're watching the recording on YouTube, it's really important that customers do set up those Azure Service Health Alerts. That's the best way to get communications for impacting event. Particularly, that's how Brain operates. We very seldom publish to our status page. And so those Azure Service Health Alerts can notify you of any maintenance retirement and any outage. And also, they're able to get you the invites into sessions like these in the future.
That's right. We'd love to keep running sessions like this. So we'd love your feedback on what works and what doesn't so that we can keep improving them. There's a survey link coming up and a survey QR code below, but thank you again for joining us.
Thank you.
Cheers. Thank you for watching another Azure Incident Retrospective. If this was your first time joining us or you're interested in hearing about Azure Incident Communications generally, we're just going to run through some quick fundamentals here. Sammy and I are both from our Azure Communications team. We exist to tell our customers what's going on. We're not part of marketing. We're not part of our customer support team. We're really just a conduit between our various engineering teams involved on call during issues in explaining what's going on.
Absolutely. When we think about outages, we tend not to think of our competitors as being other cloud providers. We tend to think of our competitor in this sense being on premises, because when customers have an outage on premises, they typically know what's going on, they get updates, their leadership's involved. And so we've developed our communications philosophy in 5 areas that try and bridge that gap between on-premises and cloud. The first one is around speed. We need to tell customers quickly what's going on. The main area of this is with our AI ops. We call it Brain internally. And Brain can tell impacted customers what's going on within about 10 or 12 minutes to those impacted subscriptions. Typically speaking, we have about 70-80% coverage of our outages are onboarded into Brain, and we're constantly working to onboard more. The next one is around accuracy or granularity. It's really important that customers understand which of their resources are impacted. Telling customers that virtual machines in East US are impacted is not as helpful as telling them which of their virtual machines are impacted, and this is accessed through Resource Health. The third one is around discoverability. It's common practice that customers go to our public status page to look for incidents that impact them, when in reality, 99+% of the time, we speak to impacted customers through the portal in Azure Service Health. Customers are able to configure service health alerts that plug into PagerDuty, OpsGenie, and so on. The fourth one is around parity. Not only parity of our hundreds of services across Azure to ensure that they behave and respond in the same way, but parity across our Microsoft cloud. We understand how important it is to have a continuous and predictable practice across all the cloud products that Microsoft offers. And the last one is around transparency. During an outage, we try and tell our customers exactly what we know in real time. And again, you've just witnessed an Azure incident retrospective where we believe that the transparent approach in understanding what happened is a key ingredient for building trust. All of those principles and philosophies can be captured in Azure Service Health, where customers can understand which of their resources are impacted, get those Brain alerts firing to their subscriptions, set up service health alerts, and get invites to Azure incident retrospectives along with post-incident reviews following an outage.
That's right. That's how we kind of think about our comms philosophy. To apply it in practice, I'll run through a quick anatomy of an outage, how you would expect to interact with communications before, during, and after an outage. So before an outage, it's really important, as Sammy mentioned, to configure that last mile delivery through Azure Service Health Alerts to tell the right people in your organization in the right way and in the right tools that make sense for them. Secondly, there's a lot of other monitoring that exists within Azure. You can configure Azure Resource Health Alerts if you want to know about every blip and pause that happens on a specific resource. We've got scheduled events to surface things within the VM, as well as a full suite of Azure Monitor to look at everything you could possibly want to observe about things that are going on with your Azure services here. We'll also touch invariably in these live stream sessions to talk about availability zones, site recovery, Chaos Studio for fault injection, storage redundancy options, all of these different features and services that you can take advantage of to build resilience into your applications and into your workloads on Azure. And lastly, beyond the specific architectural elements, we've got a bunch of guidance that's available through our docs and learn pages to talk about the cloud adoption framework to help your organization adopt the cloud, and even the well-architected framework to look specifically at individual workloads, including how you can make those more reliable. Lots of resource-specific guidance and advisor. This is just a small number of things that you can have a look at to help kind of remediate and improve your resilience gaps.
Wonderful. So now that customers have done those things before an outage, we fast forward to during an outage, what's happening. Now, myself and the team, we're interested in building systems that scale. We understand that in order for us to tell millions of customers around the world what's happening with their resources, we have to build systems that scale. And so one of the ways we do this is by investing in areas where we democratize information. And what that means is whether you spend $1 billion a year on Azure or $1 a year on Azure, we're going to tell people the same thing. We also want to tell them in the same source of truth as well, which is why we rally around single sources of truth, both internally and externally as well. In addition, during an outage, we want to tell you not only what's going on that we know and have confirmed, but at times things that we don't know. We're still ruling out a change. We're still looking at data center. Something doesn't make sense. This mitigation was attempted and failed. We want to tell our customers everything that we know so that they can make decisions and how they do this. Now, during an outage, many customers raise support tickets, and sometimes that's a great idea, and other times it's not so. It's not the best use of time. It makes sense to open a support ticket when if you've set up an Azure Site Recovery, as David mentioned, and you need help failing over, that's a great time to leverage our technical support team. If you're just raising a support ticket to confirm that the impact that you're seeing matches the symptoms that you're reading in Azure Service Health or the public Azure status page, that's not a great use of your time or the use of the time from our tech support agents as well. A lot of the time, David and I get questions around how does Microsoft respond to outages? How does Azure respond to outages? And generally speaking, we have about 3 categories. The first one is we kind of call them expected outages. We expect VMs to blip. We expect them to go down from time to time. It's not common practice. We have a multiple line SLA, but we do expect these things to happen. When this does happen, we respond appropriately. The ones that we kind of call unexpected is when we might lose an entire zone, and we might see multiple servers impacted in that zone. And typically speaking, we have a response profile for that. But really where things get unacceptable, and we kind of call it whoa, and it's a bit egregious, is when there's multi-zone or multi-region impact. This is really hard for customers to architect against. And so as a response profile to this, in addition to publishing a post-incident review within 14 days, we also try and get something out within 3 days so that customers know what we know so far. But also this is when we run the incidents like we've just had now with an Azure incident retrospective, so you can hear directly from our leaders what happened and navigate some of the complexity. And it's a great opportunity to ask our SMEs questions in real time about how the issue impacted your own environment and some of the steps that you can take perhaps to be resilient to those types of things.
That's right. So mileage varies depending on what kind of outage we're talking about here. We're starting to get into a little bit this after outage world. And as we pivot around to our learnings and our post-incident reviews, we really want to be quite intentional about how we learn from incidents and how we talk about that learning. That's why we try to resist the urge to talk about a root cause. We're not looking for one thing that went wrong. With massive distributed systems, we're looking for all of the different contributing factors that had to line up for customers to experience the impact they did. We want to learn from all of those. So we're not just looking for one thing. We also try to resist framing anything as human error, right? If a human or an operator made a mistake, that's a signal to us that our systems didn't provide that operator with the right intelligence, or that our systems lack the right safeguards to prevent that person from being able to cause customer impact. In a similar vein, we want to resist blaming the person at the keyboard. We know that we can't fire our way to become more reliable, and actually we want to encourage this culture of people to speak up when something bad is happening. Our engineers, and especially our leaders, need to know that we want to have a blameless retrospective and rally around trying to improve the situation as quickly as possible. We want to resist I told you so, but as we've talked about a little bit in this session, customers have a role to play in the shared responsibility model. And so we want to use outages as a way to educate customers about decisions and trade-offs, about the different resilient services that you could use to try to have something be less impactful for you next time that it happens. We want to resist the urge to reassure customers an incident won't happen again. We always talk about what could we do to make this kind of thing less likely or less impactful, but it's inherently, it's probabilistic here. Sometimes outages look really similar, but actually involve very different failure modes. And lastly, we want to resist the urge to tell the perfect story. Our outages aren't TED Talks. They don't start with once upon a time and end with they all lived happily ever after. We actually want to embrace ambiguity and encourage everybody to have a conversation about topics that we don't have the answers for, and where we're still trying to figure out the right path forward or the right way to improve things. That's a really important part of the story. We don't want to gloss over that. So across all of these different areas, we really want to make sure that we're learning from incidents in quite an intentional way. And this is how we show up to you in the Azure Incident Retrospectives when we have these conversations with our engineering leaders. A couple of links on screen here to make sure that you have access to our previous recordings, as well as a way to get invited to future sessions. So thank you for joining us for this incident retrospective, and we hope you learned a little bit more about how incident communications works on the Azure platform. Thank you.